right, well, students in here did well on their test, so I was pleased with how they did. There's a few things maybe they look back like, man, I wish I hadn't done that. But for the most part, they did a really good job. Hopefully you did as well if you're watching on YouTube. And just want to give you kind of a quick rundown of what to expect as we finish out the semester. As I mentioned before we even took the test, we're done with our exam material. So there's no new material between the test you just took and the exam coming up in lesson 87. So kind of give you a rundown, we've got a pretty much full-length review today, full-length review in our next lesson, lesson 85. We'll have a shortened review, the way our exam schedule works, lesson 86, and then our exam will be in lesson 87. For students in here, that's exam Friday. So we have review today, review tomorrow, short review Friday before we take the exam, and then of course we'll have the exam right after that last brief review. My goal is to review everything today and tomorrow in these next two lessons, so that lesson 86, the short review, becomes anything that you're struggling with. So as we're reviewing, if there's a concept that you're like, ooh, I don't know that I really get this too well, star it. And then on Friday, we'll go back to anything you've starred, and we'll spend a little extra time on those concepts. Does that make sense? All right, so one of the first things we did this year, after you learned how all the trig ratios worked, is I would give you one trig ratio. Maybe, for instance, that the cosine of theta is, say, 12 to 37. And then you would find all the other trig ratios. Then we kind of went a step beyond as we learned ASTC, and I could give you more information, like, for instance, that the sine of theta is less than 0. And now you had to account for the quadrant, but you would still find, based on that information alone, with the sine, tangent, cotangent, secant, and cosecant theta were at your seats. Go and find these 5 trig ratios that we're missing.
Square 37 in my head.
Do it on paper. Or if you have 50 cents, you can write a calculator. For people's math teachers, I tell you.
Not content to teach only math, they feel bent on also teaching personal responsibility and preparedness, so that their students will be ready for life one day. Such cruelty could only be paralleled to Adolf Hitler.
I'm reading his thoughts.
How do you take square root?
You ask yourself, what times itself would give that? Y'all want to help him out? What is the missing side?
35.
35. So we know the adjacent's 12. We know the hypotenuse is 37. So I believe you multiplied this to get
1,369.
correct, 1,369. This was 144. You subtracted that to get
1,225.
1,225. And the square root of 1,225 is 35.
Gotcha. You're just going to take pity on me after like half an hour and give me a calculator, right?
No.
No, he's over here trying to find the square root and angles.
Pure darkness in this man's soul.
All right, first thing I would take care of is figure out the quadrant. Even before I figure out the missing side, here's why. You find that missing side, you're immediately going to go put your ratios down. You're going to forget all about that. What quadrant are we in, class?
4.
Quadrant 4. Cosine could be positive in either 1 or 4. Sine would be negative in either 3 or 4. Obviously, that means it's quadrant 4. So sine's negative, tangent's negative, cotangent's negative, secant's positive, cosecant's negative. But based on my past experience, if you don't do it first, you're going to forget to do it entirely. From there, then, what do we get for the sine of theta, Quentin?
Negative 35 over 37.
What about the what about the tangent of theta, Jamie?
Negative 35 over 5.
And so therefore the cotangent of theta, Ethan,
Is 12 over 35.
negative 12 over 35. The secant, Chris,
37 over 12.
and we could have found that without doing any math at all. And then also, Chris, the cosecant of theta,
37 over 35.
negative 37 over 35. Right, questions on this? We're going to be able to do this on the exam Friday.
I have a calculator, yes.
If you had a calculator, that would really help. Have a calculator on Friday.
I'm not gonna be here on Friday.
You also have to be able to find exact values of trig functions, like, for instance, finding the exact value of the cosecant of 240 degrees, or, for instance, finding the exact value of the tangent of 7 pi over 6 at your C's. Find the exact values of these trig functions. Well, you might have to start with asking a question, what? Like, what is the...
Cosecant of 240.
Well, I mean, that's obviously what I'm asking. You want to break that into simpler questions. Like, for instance, what is...
240. So it would be 60 plus 180.
Okay, so the reference angle then is...
120.
The reference angle is, class? 60, because you said it's 60 plus 180, right? You're measuring from 180, so the reference angle is 60. That's the first question I'd ask. What's the reference angle? I would also ask myself the question, what
Quadrant.
quadrant are we in? Right? It'd be quadrant.
3.
And then ask myself, well, what is the cosecant of 60?
Two over square root of 3. So 2 times square root of 3 over 3.
And then finally, what is the cosecant in quadrant 3?
Negative.
And there we go. All right, so break it into smaller, simpler questions, finishing out the second one then. What's that poster say about elitism, Quentin? It's lonely at the top, but it's comforting to look down at all the little people at the bottom. It's boring to sit there waiting for all your classmates to finish, but there's a special comfort in it too. He's like, Mr. Dasky, I was sitting here minding my own business. My classmates didn't hate me 2 minutes ago. Mr. Dasky, why do you do this to me? Class, what quadrant is 7 pi over 6?
3.
That's also quadrant 3 because it's a little more than a pi. What's the reference angle?
30.
30. And so we ask ourselves, well, what is the tangent of 30?
Square root of 3 over 1.
1 over square root of 3.
1 over square root of 3, which becomes,
Square root of 3 over 3.
because we always reduce our final answers. And of course, we also ask ourselves, well, what is tangent in quadrant 3?
Positive.
And so there's my answer there. We then, of course, more recently worked with inverse trig functions, which have those limited ranges. And similar to this, except the question was not what, the question was when. So for instance, if we had the cosine of the arctangent of negative square root of 3 over 3. Or we had the cotangent of the arcsine of square root of 3 over 2. At your C's on these values.
Man, it's nice finishing first.
Who has?
They're just jealous I'm the favorite student.
Pretty much. Quentin's like, yeah, I know I'm really the favorite though, despite what he says. Jimmy's like, yeah, I really know. Ethan's like, he picks on me all the time. I pick on Chris more though, remember that. So.
Yeah, you're fat.
You never pick on me.
What?
You never pick on me.
See, that's the hard thing. I like you a lot, Jamie. You're one of my favorite students too, but I just have a really hard time thinking what to pick on you about. I don't know. It's not-
I have
Good
some things.
I feel the same way in my pre-algebra class with Aubrey. Like, I never pick on Aubrey, but I'm like, what do I pick on her about? She just sits there quietly, does her work, does a great job, works hard.
Pick
I'm
on
like,
her all day.
you pick on her all day? Off camera, you got to give me something to pick on her about. Cause I'm like, I have nothing. Like, she just does a great job, like a model student, which is, it's just hard to pick
She had
on.
better grades than me.
Well, I mean, she's in 8th or 9th grade, so it's kind of hard to compare, but
Yes, he does.
Well, yeah, that was like an innuendo to him saying yes. By far.
You're bad.
You're dumb.
All right, so let's take a look at this here on that happy note. Anytime you see something like this, you're going to want to,
Find the angle. Ask what?
even before that, let's unrationalize.
negative.
Because you're like, I don't have a square root of 3 and a 3 in the same triangle. So let's make this something that it's an easier ratio to work with.
Whatever square root of 3.
Right, okay, then with inverse functions, you'll ask the question, when is tangent negative?
Quadrant 2 is 4.
When is tangent 1 over square root of 3?
60.
30.
Oh, I had 30. I had negative 30.
Not when at this point, we're done. We've asked our 2 when questions, but normally, right, we'd say, okay, so that means I've got 150 and I've got 330. But there's that limitation on our tangent.
Negative 90 to 90.
Negative 90 to 90. Neither of these are acceptable. But one of them could be made acceptable by simply subtracting 360,
Yeah.
coterminal angle rule. If I subtract 360 from this, I'm not okay. But here, subtract 360 gives me what class? Negative 30. So this really just becomes negative 30 degrees. Now, I come to cosine. The question is,
When? What?
what? What do I do when I've got a negative angle?
Move it up to the front.
Not for cosine.
But it drops off.
Just drops off.
Yeah.
And what is the cosine of 30?
Square root of 3 over 2.
And there's my answer. All right, questions on this? Same thing on the next one, except this time I don't have to really unrationalize anything. It's square root of 3 over 2. So ask the question, when is sine square root of 3 over 2, class?
60.
And when is sine positive?
1 and 2.
But there's not a limitation on sine, remember?
Negative 99.
Negative 90 to 90, this time in brackets. Of course, tangent has it in parentheses. So that rules out my quadrant 2 angles. So 60 and 120, no, just 60. And so then I ask myself, what now is the cotangent of 60?
Square root of 3 over 3.
And there's our answer. All right, questions on these?
No.
Have your calculators at the ready, if you have them available. And, I know, bummer. So at your seats, I want you to find the sine. Let's do the nearest hundredth of a degree. Here. And let's find the sine of 257 degrees. Let's find the cotangent of 73 degrees and the secant of 148 degrees.
I don't even know what to try.
Nothing. Just sit there and feel generally unprepared for class. I should probably learn the calculator. Save me after class. We'll talk about it then.
Sad face.
Sad face, yes. Not the nearest hundredth of a degree. Just to the nearest hundredth. Sorry, we already have degrees. We're not finding degrees here.
You are?
Nope. We have degrees. We have 257 of them. We're finding what is the sine of 257 degrees. And what is the sine of 257 degrees, class?
0.997.
Negative 0.97 when we're at the nearest hundredth. What is the cotangent? This calculator's backwards, I gotta remember that.
Is that the one I normally use?
I don't even know. Of cotangent of 73 degrees.
I got 0.78, but I don't know if that's right.
That's not what I have, but it could be my calculator.
0.0023.
I got 0.30 or 0.31 when you round. So remember, you're going to take the tangent of 73 degrees, because you don't have a cotangent button, right? But then you're going to take the reciprocal of that.
Oh,
So the reciprocal of the tangent of 73.
I did the reciprocal first.
Yeah.
Ah, okay, careful. So remember, cotangent of 73 is the reciprocal of the tangent of 73. So take the tangent of 73, then take the reciprocal. Now do we have 0.3057, blah, blah, blah? All right, so maybe redo the secant of 148 then.
Oh, you got it.
And what getteth we?
Negative 1.2.
Negative 1.18 when we round to the hundredths place, the 2 decimal places. All right, now let's go ahead and do hundredth of a degree, and let's practice with inverse functions. Let's find the arc cosine of, let's see, 6.3. We can't do 6.3. How about 0.63? Let's do the arctangent of negative 5.1. Let's find the arc cosecant of negative 2.39. And let's find the arc cotangent of 0.40. This time let's do hundredths of a degree.
Man's not being done first.
And we good to go? Oh, so you're better to go than I am on this thing. I'm trying to figure this one out. All right, get very comfortable with one calculator. It's hard to switch calculators. Questions on this?
I can use
No,
that.
you're good. Questions on this? It's good exercise for me. So my brain needs a challenge every now and then, a refresher on how to use direct entries. So I actually need opportunities like this. All right, questions? Don't want to get stale as a teacher. Another thing we did was verifying trig identities. Remember, we make two sides match. So if I gave you one side of the equal sign says something like sine squared theta, and the other side says 1 minus sine squared theta cotangent squared theta. We want to work through making the two sides match. We don't work across the equal sign, remember. We're not solving for anything. We're simply making the more complicated side become the less complicated side, thereby verifying that this is indeed a true identity. All right, we get the first one.
Yeah.
Any questions on the first one?
I went a different route.
Okay, what did you do?
So on the 1 minus sine squared, I switched that to cosine.
Oh, okay, careful. It's not grouped as a 1 minus sine squared, though. So you can't do that.
I am getting the right answer.
I doubt it. Because not if you change that to cosine squared. So you have cosine squared, cotangent squared?
I had cosine squared, cotangent squared, and I changed the cotangent to 1 over tangent, and I made the tangent sine 1 over tangent, and then tangent went to sine squared over cosine squared. Flip that, cosine squared over sine squared. Oh no, I see.
So cosine of the fourth over sine squared.
I was doing the same thing.
Yeah, but say it's not going to work. So yeah, careful. Don't group something that's not grouped. If you've already started on the third one, don't.
I was wondering why it wasn't working.
Try that. What happens when I try to make them up on the spot? Yeah, now it works. Because it was not an identity before. It pretended like it was, but it was actually a contradiction. Now it's an identity. All right, questions on the second one?
I left it 1 minus cosine squared cosine.
And then you switch sides
Mhm.
and made that match? Yeah, I actually, as I got to this point, this is actually where I thought, I may want to switch sides. I was like, well, actually, no, I figured out what I need to do, but I did contemplate and thought at this point probably would want to switch sides. That 1 minus cosine squared just screams so much Pythagorean to me, I probably don't switch that early, but it's not a problem to. Okay? Questions on that second one? All right, tackling the third one now. right, questions on the third one? Feel like we remember trig verifications now? Good to go? Again, not working across and solving anything. All right, one of the earliest things we talked about was how to solve right triangles. And we've actually done a fair bit with this in physics, right? We've had to use right triangles in various problems. So for instance, if we call this triangle QDA, for instance, and we said, of course, that angle A is a right angle. And suppose we knew that angle D is, let's just say, 41 degrees. And suppose I knew that QA is, let's say, 71 inches tall. Go ahead and solve triangle QDA.
That can't be right.
What's the first thing we'll find, class?
Angle Q.
Angle Q. You've got two angles, get the third angle to be 49 degrees. And then we can solve for any one of the other sides. Let's just go with side little a, which means QD would be little a, right? And so I'll label my 41 degree angle I was given. I'll label the 71 inches I was given. I'll label the side I'm finding. What trig function do I use to find side A? The sine. I know that the sine of a 41 degree angle is equal to the opposite, in this case 41, over the hypotenuse, in this case little a. And so here I would have to do what, class?
Sine of 41,
Divide by
divide by 41.
Other way around. Alternate. So 41 divided by the sine of 41. 41 divided by the sine of 41.
62.4.
I get 62.49, blah, blah, blah. We'll round that off to, it looks like 2 sig figs, so 63 inches.
62.
Well, it should be
62
It'd be
inches.
63 because then I would bump it up the 4 to a 5. And
Something's not right here, hold on. It's 71. That's a 71. Let's try that instead, huh? 71's the opposite. Okay, I'm not sure why I wrote
108.2.
Okay,
A1.
so 71 divided by the sine of 41. And what do we get now?
108.
There we go. I was like, how's that possible? We can't get smaller than 71 because I typed in 41. 108, oh man, we're only allowed 2 sig figs, so 110 inches. And then to solve for side Q, which would be side AD, we're going to use what trig function, class? Tangent. So we're going to say that the tangent of 41 degrees is equal to the opposite 71 over the adjacent Q. I need more sleep at night. And again, we're going to have to alternate and divide. 71 divided by the tangent.
82.
Okay, 81.67 rounds to 82 inches. Questions on this? Let's do another one. And let's take a tall, skinny triangle here. And let's name it Jet. Or EJT, depending on the direction you read the letters.
Or TJE.
Tall, skinny one. And so let's suppose we know, of course, that angle J is a right angle. And let's suppose we know that EJ is, let's go with 75 inches. And let's suppose I know that JT looks a lot smaller. Let's say it's like 28 inches.
Is it higher?
Nope.
I can open the window in a minute.
What's the first thing we should solve for, class?
J.
The missing side of the hypotenuse. How should we solve for it?
Pythagorean theorem.
Pythagorean theorem. And when we do,
80.
where's my squared? Hold on, I haven't asked for it yet. And then that's squared, and then we take the square root. I hate this calculator. All right, we do get,
80.
that's only 1 sig fig though. 80 point inches, but we're not going to use that number, right, because it's a rounded value. Then we want to solve for one of our angles.
E.
Angle E. And to solve for angle E, what trig function should we use?
Tangent.
Tangent. We should say that the tangent of angle E is opposite over adjacent. And to get the angle, though, we're going to have to use the
Arctangent.
arctangent, the inverse function here. And so we'll take the arctangent of 28 over 75, and we get
20.47.
20.47, or we'll also say
20.4.
20 point degrees. And then for angle T, we're going to use what trig function?
Sine.
Tangent.
Tangent, opposite over adjacent again. This time, though, for angle T, it's going to be 75 over 28. Of course, when we take the arctangent, we're expecting the complementary angle of 70. But just to make sure we didn't accidentally do something wrong, best to go ahead and plug them both in. But it doesn't disappoint. It does come out to 70 point degrees when we round to the 2 sig figs. All right, questions on solving right triangles. All right, that's going to wrap up our review for today. Tomorrow we'll continue looking at some other things. Though we would encourage you before the next lesson, go back to chapter 5 and look over, back in your notes, and look over graphing trig functions, because it's been a while. Now we've kind of looked at it, right? We kind of looked at the sine curve, right? 0, 1, 0, negative 1, 0. When we recently talked about functions are 1, 0, negative 1, 0, 1 for the cosine, and 0 to infinity, and then going down and back up, and asymptotes, and that kind of thing. We kind of looked at that. We're actually going to practice with that graphing in our review time tomorrow, since you will have a couple of those on the exam as far as, period, amplitude, horizontal, vertical shift, inversions, things like that. So recommend you look that over before tomorrow. That way the review is more beneficial for you. All right, have a wonderful rest of your day. When the bell rings, you will be dismissed.